All right, so this is another piecewise function, and again, we have to identify all those fun things like domain and range, increase, decrease. But in addition, this particular piecewise function, notice how the graph is empty. We need to actually graph it ourselves. How exciting. So let's go ahead and do that, all right? So we'll do this. So I'm going to do this graph in blue. I'm going to do this graph in green. I'm putting dots next to them. And I'll do this graph in purple. Okay, so those will be the three different graphs I'm going to do, and that's their color identifiers. All right, so let's start with the top one in blue. So 2x plus 4. Okay, I'm going to write out to the side here to kind of explain something. Okay, so this is a linear function. Okay, how do I know that? Well, again, a couple of clues is that in this equation, x is my only variable. Of course, I have f of x off to the side, but that's y. But when x only has the highest exponent is 1, it's a line. Now, and it also happens to be in slope-intercept form. So let's go ahead and go back to that. So that is mx plus b. And hopefully you remember that m stands for slope. And again, the way you describe that would be the change of y over the change of x. Most commonly, people hear it say rise over run. Okay, and again, if there's nothing under the slope, there's always an invisible 1. So just remember that. And then b stands for the y-intercept. So y-intercept. Okay, so it's literally just the number on the outside of the equation there. So the slope of this line is actually 2 over 1. Okay, so 2 over 1 right here. It's in front of x. So 2 over 1. And the y-intercept for this is 4. It's that number there on the side. So hopefully that's a review for you. You're like, oh, okay, I remember this. At least that's what I hope you're saying. All right, so 4 is right here, the y-intercept. That's where we started. We started at the beginning. That's how I like to say. All right. And then let's go ahead and graph. So from my y-intercept, I'm going to use my slope. The 2 means it's a change of y, meaning I go up 2 because it's positive 2. So 1, 2, the 6. And then 1 to the right because it's to the right is positive, so over 1. And I'll do it again from that new point. 1, 2, over 1. Okay. And then also with the graphs, I can also do double negative. I can go down 2 over 1. And then down 2 over 1. Okay, and so now I have a pretty good idea of what my line looks like if I were to continue graphing it just like this. Okay. Now, here's what's interesting about this piecewise function. I don't get to graph the entire line. In fact, I only get to do this portion of it that's right next to it. It says x is greater than negative 3. So what that means is I can't include anything that's smaller than negative 3. So here's negative 3 right here on the x-axis, right? Okay, and that's where it crosses my line that I just made. So that means everything less than negative 3, this part right here, I need to erase. I can't include it because x has to be greater than negative 3. Okay, so I'm going to erase this part right here. Okay, now here's another thing. It says it has to be greater than negative 3. Does that mean I can include negative 3? No, I cannot. So when I graph this, what do I need to put? I hope you said it. It's a open circle, right? Because if I can't include it, I need to put an open circle there because it says it has to be greater than. It can't be greater than or equal to. It can only be greater than. Okay, so that's the first line. Okay, now we'll move on to our green line, which is the second equation. So, looking at the green line, it looks like negative 3 is my slope. So, m is negative 3. And remember, there's an invisible 1 down below it. So, I'll remember that. And then b for the green equation is negative 9, right? So, I start at the beginning down here at negative 9. Okay? And negative 3 means typically I would go down 3 and to the right 1, but going down 3 would take me off the graph. So there's actually a little trick. You can actually do double opposite. So rather than going down 3 or going negative 3, positive 1, you can actually do positive 3, negative 1. The slope is still negative, But you can do double opposites. So this time I'm going to go up 3, 1, 2, 3, to the left 1. Okay? And 1, 2, 3 to the left 1, which is right there. Okay? And then if I were to draw my line, okay, so it starts here, and then let's see if I can get this straight enough here. There we go, that's close enough. Okay, and then what is the condition? So we have to go back to the function and then highlight it. So x has to be less than or equal to -3. Okay, so less than or equal to -3. So I go back to where it crosses -3, which for me is right here. Okay, so a closed dot. And I did put a closed dot because it can be less than or equal to, meaning I can include that dot right there. But everything big, so it says less than or equal to. So everything bigger than -3 needs to go away, meaning all this right here, everything I'm kind of crossing out in red, all needs to go away because it only wants the part that's smaller or less than -3. So get my eraser here. Let's erase that. See how close I can get. Oh, that's good enough. Okay, so that's the part of the graph I need there. And then the last graph is f of x equals -3. Now this is interesting because see how there's no variable. There's not like -3x. It just says -3. Okay. And remember what f of x equals y. So the least I can do is put a dot on -3, right? Now, and here's the other cool part, the way to think about it. So it doesn't matter what the graph is, what x is. X can be 3. What's the y value going to be? -3, right? Because f of x is always -3. X could be 2. Y is still going to be -3. X can be -8. It's still going to be -3. So the way I like to think about it is it's going to be a straight line with no slope, but the only point on the graph it can touch is -3 on the y-axis. That's the only place my graph can touch, or the line can touch the graph, is at the y-intercept, or at the y value, -3. That's the way I think about it. All right, now let's look at the condition. It says x has to be greater than or equal to 1. Okay. So I'm going to put a dot right there, and again it's going to be closed because it has to be greater than or equal to. That means I can put a closed dot. And so that means everything that is less than 1 I have to get rid of because it says x has to be greater than or equal to 1. So all the stuff in red needs to go. So let me go ahead and erase that here. Okay. And I think that will take care of it. There we go. Okay, so x had to be greater or equal to 1. So that's what my piecewise function looks like. Again, that was a pretty good review of linear equations. So I'm going to go ahead and stop the video right here. I'm going to keep going with this problem in another video, but I just wanted to show you, again, how to graph these lines, and this is how you would graph them.